we want to prove this identity. Now, let's rewrite the left-hand side to bring the two cosines together, because those are the bits that we can actually put together using one of our identities. So we know that cos P minus cos Q is -2 sine P plus Q over 2 sine P minus Q over 2. So that's going to be -2 sine 4x over 2 sine, and make sure we get this the right way around, -2x on 2. And don't forget the plus sine 2x. I haven't put it in a very good place on the screen. So that's going to be -2 sine 2x sine -x plus sine 2x. And of course we know that sine is an odd function, so sine of -x is negative sine x, so we can get rid of this minus in the front and have sine x instead, and then we've got plus sine 2x, and then we can actually factorize. So we'll bring out the sine 2x, and then we've got 2 sine x plus 1, and there we go. So that's the right hand side, so that's proven. So hence or otherwise find the exact general solution to this equation. Alrighty, so what we can do is replace the left hand side here with sine 2x, 2 sine x plus 1 equals 0, and then we've got sine 2x equals 0, or sine x equals -1/2. Now, for sine 2x to be 0, so where is the sine 0? Let's think about that. It's here and here. So 2x must be equal to n pi, which will lead us to x equals n pi divided by 2. Okay. Over here we would have, so -1/2 would be down here at, so pi by 6 below, so that's going to be -pi by 6 plus 2n pi, or x is, the other one would be here, -5 pi by 6 plus 2n pi. So we've got x is n pi by 2, -pi by 6 plus 2n pi, or -5 pi by 6 plus 2n pi, for n being an integer.